Wait for it. Make sure my microphone is on. Okay. So, can I have somebody raise their hand and tell me what this shape is and what its area formula is? Anna.
It's a circle.
Okay.
And I think that it's...
I got that wrong.
I think it's
Yeah.
I think it's A is equal to pi times the diameter or pi times r times 2.
That's circumference, not area.
Okay, wait.
Alright.
I don't know yet. Okay, pi r squared.
Pi r squared. There it is. Okay. What about this one? Yeah.
It's a triangle.
What's its formula?
1/2 length times width.
Perfect. Number 3.
It's a rectangle.
Kaylin, thanks for raising your
Sorry.
hand. Go ahead.
It's a rectangle.
What's its formula?
It's length times width.
Okay. Number 4.
That's a parallelogram. and
Why
it's-
not a rectangle, Michael?
Because the angles are not 90 degrees.
I agree. They might be, but we can't assume anything.
Nah.
I agree. So what's the formula for a parallelogram?
It's still length times width.
It is still length times width, or base times height, right?
Yeah.
Now, if I gave you a parallelogram that looked a little bit more like a parallelogram, it might look like this, right? Now, be careful because when you're doing length times width or base times height, remember the side length, because that's not 90 degrees, isn't necessarily the length I'm using. It's the height of the shape. Now, the other thing to be careful of when you think about these things like base times height is that there's a difference between altitude and height, okay? So altitude, like literally how tall something is off the ground, but be careful because here, like if I oriented this triangle this way, this is the height, right? Has nothing to do with its altitude, right? The height is often the distance between different parts of the shape. Keep that in mind, okay? What about number 5? What kind of a shape is that one? Someone raise their hand, please. Trapezoid. Can someone define trapezoid for me? Yep.
It's a quadrilateral with one set of parallel lines.
You got it. A quadrilateral with one set of parallel lines. Perfect. What's the difference in geometry between the little tick marks and the arrows? Is there a difference? There's a huge difference, yeah.
So the marks seem like the same length and the arrows mean parallel.
Yeah, these mean congruent, these mean parallel. Because this one here is not congruent. Does that make sense? Can anyone think they remembered the area formula for a trapezoid? Uh-oh. Okay, so you kind of split it into like a rectangle and a triangle. That'll work. But if I wanted one single formula for trapezoid.
Hey Siri.
Oh, nice one. Nobody? I went over it in my video last time. Yeah, in the beginning during the bell quiz. So many of you watched it, I'm sure. That's a problem because I'm going to assume on it today. 1/2 height, base 1 plus base 2.
Oh yeah.
So this is my base 1. This is my base
I knew
2.
that.
Oh, yeah, now
Okay,
we all know it.
Oh,
Yeah, okay. So again, careful of the height because the height is not necessarily how tall it is, right? The height is defined as the distance between the parallel sides. Good? Okay, what about number 6? What kind of a shape is that? Some sort of quadrilateral with one pair of parallel sides. So it's a trapezoid. Yeah. This one's a trapezoid and this one's a trapezoid. Right?
Right.
You guys with me? Do you see that it's a trapezoid?
I see.
We see.
I see.
Okay.
It's
It's a weird looking one.
It's a little funny.
Why does it look weird?
We don't judge. It's because just like normally when we see trapezoids, it's like the two lines are like, you know.
Mirror.
Ah.
My trapezoids did
But based on Carrie's definition, a quadrilateral, one pair of parallel sides. Doesn't that fit?
Yeah.
Yeah.
Fine by me.
Okay, what? So then same area shape, right?
Yes.
Okay. Or area formula. That's fine. So what's the number 7?
Also a trapezoid.
Also a trapezoid. Same area formula. With me?
Yes.
We're good?
Solid.
Okay, so go ahead and get out notes. We're gonna start our lesson today.
Day 2.
Okay,
So.
so
He's thinking like, oh, this class is easy.
last time we went over on integral state 1 in the video. I went over we started estimating the signed area between a curve and an x-axis. Sometimes people define it as the signed area under a curve. I don't like that definition because when our graph is below the x-axis, under would go to negative infinity, right? So you're going from the curve to the x-axis, okay? Now signed area, okay, as a reminder from the video lesson you all watched and studied, right? Sign plus or minus sign. What that means, area technically can't be negative, but signed area means any shape above the x-axis is positive and below the x-axis is negative. So direction is taken into account just like on velocity. Got it? We're doing okay? Now last time we went over Riemann sums. Riemann is just the last name of a guy. When I think of Riemann, starts with R, rectangle sums. The idea is that the easiest shape to find the area of is a rectangle, okay? So what the guy, I don't remember his first name, Riemann did is he said, well, what if I take really tiny rectangles and fit them as best as possible under curved shapes, and I use that to estimate, right? Well, it turns out and then the first thing that they did to try and make the rectangles a better estimate is move from left and right sums to midpoint sums, okay? And that balanced it out. Now, there was still an extra corner, right? That was over or underestimating too much. So then the next way they make our estimate better is they decided that a rectangle wasn't the best shape, that a trapezoid is. Okay, so let's take a look at this shape. How about, okay, so let's say I want to estimate the integral from 0 to 4 of this. So that would be the area from 0 to 4 between my curve and the x-axis, right? Everybody good? Okay. So last time, if I was going to draw a rectangle, it would look like this. But I have all this extra area here, right? So what they realized is that what if instead I just connected those endpoints? Now I want to go look at that. I want to look at number 7 from that warm-up. And number 6 and number 5. Do you see the trapezoid? What angle does the x and the y-axis make? 90.
Oh yeah, that's
Right? Making those parallel. I now have a quadrilateral, 4 sides with 1 pair of parallel lines. Right? That make sense? Okay. So let's draw all of our trapezoids here. If I was going to have you estimate using 4 subintervals, so that would be an n of 4. They look kind of weird? Sure. But are they trapezoids? Absolutely, yeah.
Did you still count the middle red? then one has a trapezoid or a rectangle?
I still consider it a trapezoid because depending on the length of your the x value, the width of each trapezoid, it's just coincidence when it ends up balancing out to become a rectangle. And the area formula is the same. It's just that my base 1 and my base 2 length are the same value when I plug them in. Does that make sense? Okay. Good question. Okay, anyone else? We also sometimes have ones where an endpoint might go to the axis and it's a triangle, but we're still going to consider it a trapezoid, but with maybe base 1 length of 0 or something like that, so that we can use the same formula throughout, because what we're doing is already complicated enough. Does that make sense, Nate? That's a great question. Okay, anyone else? Okay. All right, so now what I want to know is for that first trapezoid, I want to know how to find base 1. I want to know how to find base 2, and I want to know how to find height. Okay, I'm going to give you 30 seconds with your neighbors. Okay, how do I find base 1? How do I find base 2? And how do I find the height?
So 1, and then so base 1. So base 1 would be this line right here. Plug to the average. So base 1 would be where from 0 to where to where if you plug in 0 in the main parent function is where you get there. So you just plug in 0 in this one, so there you go. Let's see, 1/2. Yeah, 1/2.
Okay, let's come back together. Anybody think they have an idea? How do I find? Yeah, Kate.
We were just saying, like, so the x from the 2 points, so in this case it would be like 0 to 1, so that x, that's just 1.
Okay.
That would be the height, because that's the distance between the 2 parallel lines.
Okay.
And then the y is just what the base 1 and 2 are going to be on each side.
Good. Perfect. So on this one, in terms of this formula, my trapezoid formula would look like that. Perfect. Okay, the y's are my base 1 and my base 2, and the height, which is the distance between my parallel sides. So that's why I tried to make a big deal last time, like 2 minutes ago, about the height doesn't mean height, how tall I am, or altitude, how above the ground I am, right? Which technically isn't altitude anyway, it's how above sea level I am, right? But we don't even think of that anyway. Okay, but the height is the distance between my features on certain geometric shapes. On a triangle, it's the distance between the base and the vertex, right? On a parallelogram, it's the distance, the right angle distance between my congruent sides. On a trapezoid, it's the distance between the parallel sides, okay? And we're gonna think generally now. What would we call that height generally? Yeah. It is my dx value. Good. This right here is my dx. Remember last time we talked about in the video, it said dx was the distance of each subinterval length. Makes it easier if the dx is the same, but every once in a while I don't have enough information to do that, so you use the data in the table, right? But half your homework had you do, in the book, had you do dx values that were the same throughout the interval, and half had you use data from a table, okay? Just so you know, because the point of this class is our AP test at the end, well, and our love of calculus, right?
Ah, yes.
Okay, but they make sure that about a third of the test has to do with tables, a third with graphs, a third with word problems. Okay, so that's why we kind of go through different ways when we do this, okay? Now, can you guys, do you need my help to finish out the other 4 trapezoids? Okay, I want you to find for me the value of this estimate. Okay?
From 0
I want from 0 to 4.
Oh, 0 to 4, okay.
From 0 to 4, using 4 subintervals. I wrote out the formula for the first trapezoid. Okay? Now, as you're going, I'm just going to talk a little bit about AP grading. If you just have a numeric answer, usually one of the points is allotted for the fact that you did a trapezoid sum. So if you're not showing them these formulas, or a drawing of some kind, drawing out the trapezoids, then it's not going to be clear to them that you did a trapezoid sum. So even on your calculator, make sure you're writing out your thinking and your work, okay? I'll give you a minute or so to finish out. Remember, that formula is just the first trapezoid, but I want all of them.
1, 2. What interval 2? It's 1/2 times 1 times F1.
Finish already?
F2.
What'd you get? 13? Is that what you got?
Except we can't do that right now because we have
Well, we have an equation.
But yeah. But I just meant like because like F of 0 there.
F of 0, plug in 0 to the main function. So 1/2 in parentheses 0 minus 3 squared plus 2.
So I just want to understand your question.
So like
This looks great for work for that one, so now I actually want you to find that estimate.
okay, so like is that like 4?
I think I have.
Oh, so you have to plug 0 in for x. So 0, so right, so 0 minus 3 and 9 halves plus 2, so it's 6.5. Because we have the formula, we can actually find the f of 0 length.
Oh yeah, I forgot we have this.
Yeah, yeah,
Zero
okay.
squared.
I was so confused for a second.
Okay, oh yeah. Well, I forgot what the exponent. Oh no, it's if the exponent's 0. Then it's 1. Okay, yeah, yeah. Okay, wait, I did this completely.
Right, and you can do that with dx. You can be like, if your dx is not 1, you can be like 1/2.
3.5 plus.
Because like, for the dx, it's like,
So like this formula.
Oh, I just need to do
1/2 x minus 3 times like negative 1.
Okay.
And then du is the distance of each circle. So this will be like, so we just plug in, yeah, so there's 1 minus 3, okay.
Wait a second. Can't we just put in your calculation?
Another 30 seconds. Guys, remember how the video taught you how to check it exactly? Math 9. Math 9. Yeah.
I was just wondering, so when I use the integral function, really, like, I wasn't a little bigger here, but. Okay, when I use this function out there, like, I figured I'm gonna use it, it's this one, and it wants to, like, keep the bound, I don't know which, like, way you can put stuff in.
Try just typing 0.
0.
And then enter. Did it work? And then now type, does it say upper bound now? Now type
Yeah.
4.
It does work.
Yeah.
So,
And there's an integral function also in the calculator mode too. You don't have to just do it on the graph. Okay, so from what I'm hearing, that this is 13, right? And then the actual one, if you practiced your math 9, was what, 12 2/3, right? How are we doing, okay? Can you guys see why the trapezoid is a much better shape? Right, it's taking out, yeah, it's still an overestimate right here, but it's taking out so much more, that whole corner of area it got rid of, right? How are we doing, okay? Okay, now, how could I have gotten the 1, the dx value, if I had just told you I wanted 4 subintervals of equal length? I wanted 4 trapezoids. We're gonna call that n. N is my number of shapes I want, or the number of subintervals. Okay? Say it again.
The like upper limit minus the lower
So this dx is always equal to b minus a over n. So my a to b is my domain, right? N is my number of subintervals or number of shapes, right? And then my dx is the length of each subinterval. Now again, I want to point out that that only works, the dx equals b minus a over n, if each of my subinterval is the same width. If each of my rectangle or each of my trapezoid is the same width, right? But sometimes I don't have enough information to do them all the same width. I just use the data in the table. That's what the second half of the video from last time went over, right? Okay, how are we doing? Any questions? We're gonna try another one. Nobody's asking me questions, but I see a couple concerned faces. Kate.
Well, how, sorry, I was just gonna ask, like, how much will they give you points for, like, the approximation? Like, how over or under of an estimate it is? You know what I mean?
Say your question one more time.
So, like, since this is about 13 or whatever,
Yeah.
how high or low would it have been for it to still be right?
They would have only taken 13.
Only 13.
Because the question would have been not find it exactly. Because we have the formula, you've got your calculator, where the question would have been use a trapezoid sum to estimate this, and then it would probably say, and then describe its meaning in terms of the story. Because so they would only have taken the 13.
Okay.
Does that make sense?
Yeah.
Yeah. Good. Anyone else? Okay. We're gonna do another one now. I'm gonna try and leave this up here. My physics friends, go in real quick and double check your calculators in radian mode. We're gonna do a trig function. Okay. Now, I'm going to get you started on this one, okay? I'm going to get you started on this one. Okay, so what I want is a trapezoid estimate with 4 trapezoids of equal length, okay? To estimate 0 to 1.1 pi. 1.1 pi is not a unit circle angle. That's on purpose, okay? So, my first question to you, again, I'm going to get you guys started on this and give you time to finish it. My first question to you is, does anyone have any ideas where I should start? What should I do before I do anything else? Anyone? Find my dx. D of x, very different, right? But you're right. Cindy says I gotta find my dx. She's right. So, find my dx, exactly. Because no intermediate rounding allowed. I wanna know my dx exactly. What's my dx exactly?
1.1 pi.
Point what? 1.1 pi over 4, or 0.275 pi. Either way you want to work with is great, right? So what Daniel did, he took the 1.1 pi minus 0, right? 1.1 pi minus 0 over my 4 subintervals. So that is my dx value. I'm doing it in the same color for the video, but I don't know if it You want me to go like this to separate the problems? Maybe that made
It
it
made me
worse.
so proud when someone asked about the secret word.
Somebody, actually I had a couple people ask about the secret word. But then they were like, I thought it was this, was I right? I was like, I honestly don't remember. Like I literally had no remembrance. I was like, all I remember is I couldn't spell it very well.
Yeah.
So it was probably through or thorough. I think that's what I said, because I never spell those words right.
I think it was thorough.
Yeah, or pole, or chords. I always mix those up too. Yeah, well. I can't be good at everything, you know. All my friends would feel bad, you know what I mean? Okay. So now, what's next? What do you think? What should I do next? Now that I know my dx value, what should I do next?
Divvy it out. Divide it out.
Divvy it up, yeah. Okay, let's start doing our very first trapezoid here. 1/2 times 0.275 pi. There's my 1/2 height, right? Times my base 1 plus my base 2.
Oh.
So that right there is going to represent. Now notice my first trapezoid is a triangle, right? But I can still use the trapezoid formula to find it. Okay, it's just going to end up being that my sine is 0, my base 1 length is 0. Notice how if my base 1 length is 0, do you see how it just becomes 1/2 base times height? Right? The trapezoid formula will work for rectangles, trapezoids, triangles. It takes into account all of the shapes. Does that make sense? Okay, good. So now set up your next trapezoid. That's just the first trapezoid. First triangle, trapezoid. Normally I'd give you a little bit more time and have you guys come up and write these. It's just because it's a Wednesday.
One. Base 2.
So you're just doing that every time? Like it was 3. But then
It's the same.
Do that right.
but that's
Actually, no.
As long as my dx value is the same, absolutely.
Is this right? Did I get that right?
I mean, I don't remember because I just kind of make it up as I
Oh,
go.
okay.
That looks,
Maybe.
I think so.
If I
For some
did
reason, I remember I thought there was a 9 in it. We did the same one last class. That,
Yeah, leave it off for a minute to make it swing around.
The place is just side hooks, right?
yeah.
Switch it around
And it's
backwards.
1.15. Oh my goodness.
So many pies.
Well, and then also,
If you're getting the hang of it and you want to notice some ways you can make the typing in easier, like maybe factoring out the 0.275 pi over 2 and timesing that by all that at the end, you can absolutely do that. Just be careful. Okay? It's 0.275 pi. Oh, you're just getting that. Okay. Well, just do it as a trapezoid again.
But they'll hold us to the middle section, right? The middle of any.
If they're gonna have to.
Yeah, but then you don't even have to visualize that at all. And also the other thing is that that's actually not perfectly in the middle. Because I did that on purpose. It looks like a rectangle, but it's actually slightly not because I on purpose chose non-circle. So I can't promise that that's going to be right in the middle.
I have an idea.
No, if it was, and you realize that, yeah, sure you could, but to be able to make it easier in your thinking, just always do the trapezoid rule, right? Because the formula is the same. If the base 1 and base 2 length are the same, it'd be the same because then the 1/2 and the 2 of that base cancel out. It's the same. Same with the triangle. No, it's not. No, it's hard to visualize this. This stuff is hard.
We didn't talk to myself, we do the same.
Oh.
I think maybe you're thinking
That's where I got stuck.
Let's see. You guys get something? Anybody get something? Yeah.
Number 7.
But can you?
Yeah. Yeah.
It's like, it seems like it has multiple equations, but doesn't give you.
Oh, yeah.
I'm pretty sure on that. Yeah, but I'm pretty sure on that one it specifically told you they were geometric shapes. Meaning you use the area of a circle, the area of a triangle. Like it wasn't ones that were like parabolic or sine or something. I picked that one on purpose because it specifically said, given the fact that you could use your normal geometric shapes or something like that. Does that make sense?
So they're adding.
So you think back to regular geometry, the area of the circle, the area of the triangle. Yeah. Good. I'm glad that's a homework question because I just looked at that graph and I was like, babe, if that's your sine function, you have to work on your graphing because that is not a great sine function graph there, my friend. Absolutely. Usually what'll happen is it'll say like using, okay, so 30-year test is tables, right? So the majority of the time when you have Reem on some questions, I don't know, majority of the time, a lot of times they use the table calculus because that's the best way we can actually estimate. I don't know the actual number because I don't have the lines connect, I don't have the formula. Does that make sense? Okay, you'll have at least one, usually two, FRQ parts about results. Usually there's one left or right and one right, like a part A or something.
No, it didn't. It's just doing this stupid thing. So many
That's not necessarily true. You'll see on the homework tonight actually gave you a table but there's more information given and you'll see I just don't want to give the how to do it. Okay, we gotta move on, you guys. So hold on. You guys, couple things. Does anybody think they got the estimate for this one?
Maybe. I think maybe.
Okay, tell me.
0.8. Or estimate or like what I got.
No, I want the estimate. You didn't estimate it, Amelia.
I got 1.82817.
1.8217.
817.
Good. Anybody else get that? Couple that did it. Okay. Then what is the actual one? Anybody type it in, which technically in this case is still an estimate because it's an irrational number. So I'll do a less squiggly line. All right. It's 1 point, what? 1.11. Okay, good. Now, couple things. You guys, we only have 11 minutes and I need all of them, okay? Focus here. Couple things. Some people are wondering, well, what about this last one? That is a bow tie, for sure not a trapezoid, right? Okay? So I want you to imagine what would happen if I took that bow tie and I split it up into its two separate triangles, okay? So pause here. It would be from this length here, which is what? 825 to pi, right? Or I guess I should do that, right? 825 pi. That would be this length right here, right? So it would be 1/2. This is its base length, right? And its height is my sine of 0.825 pi. Does that make sense? Okay?
What?
Well, so this is a triangle. So if I was just focusing on this one here, it would be 1/2 base times height, right? And the base would be the distance between pi and the 0.825 pi. Is that fair? You guys, is that good? Okay. Then I would add that to this one, which would be 1/2, and I would go from 1.1 pi minus pi, right? That's my base length, times sine of 1.1 pi. And then I would add those two things together, right? If I simplified this, what would I get? Okay, 1.1 pi minus 0.825 pi. Is that fair? Which is what?
The dx. No way.
Look, and imagine taking this and distributing it in. Do you see how that's the two triangles? The nice thing about the trapezoids is whether my actual shape is a rectangle, a triangle, or a bow tie, just doing the regular trapezoid rule takes care of all of it.
Yay.
I didn't have to split this bow tie up.
Like, who figured this
Right?
out? How did they think of that?
Newton. Pretty smart dude. Yeah. Pretty smart dude. Hey.
Me and him, we go way back.
Way back. Okay. I mean, if he was single today, right? Okay. All right. Last thing in the last 10 minutes. Last class in the video, I had you guys look at where my left and right sums were increasing and decreasing. It was where the estimate was an over and under estimate, right? Notice how on this one, I have portions that are increasing and decreasing. And on this one, I have portions that are increasing and decreasing, right? I'm going to give you 2 minutes is all I can give you. I want you to see if you can decide when will the trapezoid rule be an over versus an under estimate of the actual integral, okay? So when will the trapezoid rule be an over versus an under estimate of the actual integral? Use our two examples, and I left those on the board on purpose so you can see where the trapezoids are outside the shape or under the shape, okay? So you have 2 minutes, go.
If functions calculate down, it's going to be underestimated.
Oh, yeah.
But with like here's the sign, it can be both calculated down and up. Wait, no, it's because it's in the negative. I get it now. Because it's in the negative and the calculus start moving downwards. So if it's concave up in the positive, then that means it'll be under. Wait, hold on. No, yeah, it'll be over.
Yeah, that's what that's called, the secant line. Yeah.
But if it's concave up in the negative axis, then it's going to be underestimate. Yeah, because the trapezoids are going down towards it. So basically, if it's concave,
Okay, like
Yeah.
20
so
seconds.
it's concave.
Ah!
Yeah, if it's concave, up in the positive, then it'll be under, and then it's vice versa for the opposite the axis. Yeah. And then when it's concave down, it's
Okay, let's come back together. Sorry if that wasn't enough time, but it's a Wednesday and we gotta get through it. Caleb, you wanna give it a try? Okay, listen up. Caleb, talk loud.
I just said if it's concave up, then it's an overestimate. If it's concave down.
Okay, so Caleb thinks that if it's concave up, it's an overestimate. And if it's concave down, it's an underestimate. Do you guys agree?
Yes.
Michael?
And then to add on to that, if it's if it's on the negative side of the x-axis, then it's flipped. So if it's concave up, then it'll be an underestimate because the trapezoids are like facing downwards now.
Ah, this comes up a lot. Okay, let's talk about this. Thanks for bringing up the negatives.
Hey, no problem.
Okay, so here, you guys agree if the graph is above the x-axis, do you agree that these are overestimates? The trapezoid goes out of the shape, right?
Yes.
And on these ones, they're underestimates, right? Now, so what Michael's bringing up is here. This is a big confusion for people sometimes, okay? But I want you to be careful, okay? Hold on. If I were to take this shape, oh, I can't use green on the video. Don't use green, don't use green.
I
Okay,
swear.
if I were to take this shape, hold on, and zoom in, okay? I'm gonna zoom in on what's going on here. Here, okay? This is this one. Is that fair? Notice how the triangle, right, is a smaller area than the actual shape. Do you agree? So that might make you think, because this is concave up, that it's an underestimate, because the triangle is a smaller area, right? But here's where you need to be careful with your negatives. A smaller negative area. A smaller negative area is a bigger number, right? Think of it like the blue would be like negative 0.9 and the actual would be negative 1. So even though it's a lesser area, it's still a bigger number. So does it flip? No, concave up is always an overestimate. Because the smaller negative number is a bigger number in terms of our number line, right? Does that make sense?
Yeah.
Okay, good.
I didn't really
So,
do it that way.
on the video, I had them add this increasing and decreasing to their ultra lavas, but I wrote it in a way I like better here. So if you did that in the video, erase it and write it again differently. But we're gonna add this here now. So concave up is always for trapezoids an overestimate. It does not matter if the graph is located above or below the x-axis, because negatives mess everything up. And then if it wasn't a Wednesday, I was going to have us explore another item, but it is, so we're going to just write it out. It turns out that there's something that fits this pattern. These are exactly opposite, and there's one that's exactly opposite of trapezoids, which is our midpoint sums. We just don't have the time. Those are a little harder to see. Okay, so this is what should go on your ultra lava. Yes, the top part is a repeat from what the video said. I just like the way it looks better here.
Can we leave it how you read it?
Huh?
Can we leave it how you read it originally though?
Sure, however you want.
Whatever floats your goat.
Yeah. And then the bell's gonna ring in the next minute. Okay, I'm stamping 3 things on Friday. The bookwork from last time about left and right and midpoint sums. Tonight's worksheet, which is FRQ practice of sums. And the corrections I asked you to do on your own paper over the long weekend.
Facts.
Okay? Anyone have any other questions? Great job. A minute to spare on a Wednesday.